In class-based programming, the factory method pattern is a creational pattern which uses factory methods to deal with the problem of creating objects without specifying the exact class of object that will be created. This is done by creating objects via a factory method, which is either specified in an interface and implemented in implementing classes, or implemented in a base class, which can be overridden when inherited in derived classes, rather than by a constructor. Definition: the factory method pattern should not be confused with the more general notion of factories and factory methods. The factory method pattern is the best-known use of factories and factory methods, but not all uses of factory methods are examples of the factory method pattern. Only when inheritance is involved is it an example of the factory method pattern. More basic uses of factories are not examples of the factory method pattern, and may instead be referred to as the factory pattern or a simple factory. These are discussed at factory. The essence of this pattern is to define an interface for creating an object, but let the classes that implement the interface decide which class to instantiate. The factory method lets a class defer instantiation to subclasses. Creating an object often requires complex processes not appropriate to include within a composing object. The object's creation may lead to a significant duplication of code, may require information not accessible to the composing object, may not provide a sufficient level of abstraction, or may otherwise not be part of the composing object's concerns. The factory method design pattern handles these problems by defining a separate method for creating the objects, which subclasses can then override to specify the derived type of product that will be created. The factory method pattern relies on inheritance, as object creation is delegated to subclasses that implement the factory method to create objects. Example implementations: Java. A maze game may be played in two modes, one with regular rooms that are only connected with adjacent rooms, and one with magic rooms that allow players to be transported at random. The regular game mode could use this template method. In the above snippet, the maze game constructor is a template method that makes some common logic. It refers to the makeRoom factory method that encapsulates the creation of rooms such that other rooms can be used in a subclass. To implement the other game mode that has magic rooms, it suffices to override the makeRoom method. PHP, another example in PHP follows, this time using interface implementations as opposed to subclassing. It is important to note that the factory method can also be defined as public and called directly by the client code. Limitations: there are three limitations associated with the use of the factory method. The first relates to refactoring existing code. The other two relate to extending a class. The first limitation is that refactoring an existing class to use factories breaks existing clients. For example, if class complex were a standard class, it might have numerous clients with code like. Once we realize that two different factories are needed, we change the class. But since the constructor is now private, the existing client code no longer compiles. The second limitation is that, since the pattern relies on using a private constructor, the class cannot be extended. Any subclass must invoke the inherited constructor, but this cannot be done if that constructor is private. The third limitation is that, if the class were to be extended, the subclass must provide its own re-implementation of all factory methods with exactly the same signatures. For example, if class strange complex extends complex, then unless strange complex provides its own version of all factory methods, the call will yield an instance of complex rather than the expected instance of the subclass. The reflection features of some languages can avoid this issue. All three problems could be alleviated by altering the underlying programming language to make factories first-class class members. Uses: in ADO.NET, IDB command create parameter is an example of the use of factory method to connect parallel class hierarchies. In Qt, main window create pop-up menu is a factory method declared in a framework that can be overridden in application code. In Java, several factories are used in the JAVAX XML parsers package, for example JAVAX XML parsers, Document Builder Factory or JAVAX XML parsers, Sax Parser Factory. See also, Design Patterns, the highly influential book, Design Pattern, Overview of design patterns in general, Abstract factory pattern, a pattern often implemented using factory methods, Builder pattern, another creational pattern, Template method pattern, which may call factory methods, references. Fowler, Martin. Kent Beck, John Brandt, William Opdyke, and Don Roberts. Refactoring, Improving the Design of Existing Code. Addison Wesley. ISBN A0-201-48567-2. Gamma, Eric. Helm, Richard. Johnson, Ralph. Lasides, John. Design Patterns, Elements of Reusable Object-Oriented Software. Addison Wesley. ISBN A0-201-63361-2. Cox, Brad J. Object-Oriented Programming, An Evolutionary Approach. Addison Wesley. ISBN A978-0-201-10393-9. Cohen, Tal. Gill, Joseph. Better Construction with Factories. Journal of Object Technology. Retrieved March 12, 2007. External links, Factory Method in UML and in LaPass 3, Consider Static Factory Methods by Joshua Block.